Now we want to go from polynomial inequalities to rational inequalities, where we have a polynomial over a polynomial. How do we determine how to solve these problems? Well, here's an example. We went ahead and graphed 3x plus 3 over 2x plus 4. Couple of things that we have the skills to notice on this particular graph. One, we've already learned how to determine where does it cross the x-axis at. And that's determined by the numerator. Where does the numerator go to 0? Well, that's true if x equals -1. So I have a point right there at -1 where I know the graph intersects the x-axis. Likewise, we can find out where also there's a rip in the graph because there's a vertical asymptote where the denominator crashes and goes to 0, and this was true at -2. So you can see here at -2, I have a rip in that. So those 2 points, where the numerator becomes 0 and where the denominator becomes 0, that helps us to set up our sections to test. So my 3 sections, and this one I have, is from -infinity to 2. I have from 2 to 1, or to -2, sorry, -2, -2 to -1, and the last one is from -1 to +infinity. So those are the 3 areas that this function, or this function divides the graph into. And then from there, our process will be the same. We'll test in each section if this is true or not. And if it's true, we'll light that up on our graph. If it's false, we won't light it up. So let's look at an example.